Happy morning, my dear children. Last class we discussed about that absorption, differences between chemical and physical absorption, positive catalysis, homogeneous catalysis, heterogeneous application, etc. Am I right? The second volume. 10th lesson, am I right? Okay. Anyhow, today our learning objectives to learn about one of the important question, very important question, intermediate compound formation theory. This is our learning objectives to learn about intermediate compound formation theory. And also having some important 2 mark, 3 mark question, promoters, catalytic poison, autocatalysis, negative catalysis, etc. we are going to discuss. Here, what is about the intermediate compound formation theory? Here we are taking two reactants. That is, one is reactant A and another one is the reactant B. Both the reactant combines to react with the help of the catalyst C. Okay, A react with B to form AB. Am I right? In the presence of catalyst C, we get an intermediate product. First of all, we get an intermediate, that is, A combines with C to form AC. The AC is an intermediate. The AC again combines with other reactant to form other reactant B to form AB plus C. Okay, that's the concept. A combines with the B to form AB. That's the product. In the presence of catalyst C. Clear? First, A reacts with the catalyst C to form AC. The AC is the intermediate. This AC on again react with other reactant B to form AB, and the catalyst C is regenerated. We have the equation. We have 4 equations. Example. And also the promoters, don't forget that the promoters. What is about the promoters means certain substance promote the activity of the catalyst. That are having some examples. Example, Habe's process. Very important question. And about the catalytic poison, certain substance decrease the rate of the reaction or maybe completely destroy the activity of the catalyst is called as a catalytic poison. And about the autocatalyst, certain substance, here the reaction, during the reaction time, one of the product acts as the catalyst. One of the product is first formed. That product is acts as the catalyst. That is called as an autocatalyst. Have you an example? And about the negative catalysis. Previous day I told you about the negative. When we are adding certain substance, the rate of the reaction is decreases. The decreases, that we call as a negative catalyst. We have some example. Here you have, please. Today we have a question very important. These are all questions, very important questions. Repeating board exam question. Okay? Please all of you take the note, we can write the equation. Okay? Today we have to learn about the intermediate compound formation theory. Intermediate compound formation theory. Okay, what is the concept of this question means? Here, the catalyst may combines with one or more reactant to form an intermediate. Clear? First, the catalyst react with any one of the reactant to form an intermediate. Clear? That intermediate again react with other reactant to form products, and also the catalyst is regenerated. Here, what is the concept here? Can you understand? It is one of the, for example, I am writing the example. A by means of the catalyst C. Okay, that means A combines with the B to form AB. The catalyst is C. First of all, the reactant, here I have two reactants, that is one is reactant A and another one is reactant B. First A react with the C, clear? A react with the C to form AC, to form AC. This AC is the intermediate. Okay, this AC is the intermediate. We can take as equation number 2. This AC again react with another reactant. Okay, another reactant means me. Okay, the AC again react with another reactant with B to form A, B plus the catalyst C is regenerated. Catalyst is regenerated. That's the mechanism of the reaction. Clear? Can you understand? Okay, anyhow. It is the intermediate compound formation theory. It is one of the homogeneous catalyst reaction. Which genus catalyst reaction? Homogeneous. Don't forget that. It is a homogeneous. Catalyst reaction. Intermediate compound formation theory is a homogeneous catalyst reaction. The catalyst may combines with one or more reactant to form an intermediate. This intermediate reacts with other reactant to form a product and the catalyst is regenerated. Okay. Let us begin to discuss about the example. I think that we have 4 examples. The first one example is about the Friedel-Crafts reaction. Friedel-Crafts reaction, that is the reaction between, example 1, the reaction between benzene. What is the formula for benzene? C6H6 with methyl chloride, methyl CH3 Cl, methyl chloride. Here we are using one of the catalysts is about that anhydrous aluminum chloride, anhydrous aluminum chloride, AlCl3, aluminum chloride, anhydrous aluminum chloride. Here, one of the hydrogen from benzene combines with the Cl to form HCl. So what's the product? What is the remaining product? C6H5 CH3. So we get C6H5 CH3 plus HCl. Okay. Here, so this is our expected product, that is A on combines with the B to form AB in the presence of C. What is A? Benzene. What is B? Methyl chloride. And what is AB? That is a toluene, otherwise called toluene. Okay, T-O-L-U-E-N-E, toluene. Clear? Can you understand? So, A reacts with B to form AB in the presence of C. C is the catalyst and A is what? And reactant A is benzene and reactant B is called as a methyl chloride. And the product is AB, that is about the toluene, and the catalyst is anhydrous aluminum chloride. Okay, how can we explain the reaction? That means, first of all, here methyl chloride on reacts with aluminum chloride. The reactant, any one of the reactant first combines with the catalyst. Okay, here any one of the product, first we are taking any one of the reactant, first we are taking the reactant, that is about the methyl chloride, CH3Cl, methyl chloride on reacts with aluminum chloride. Okay, methyl chloride on reacts with aluminum chloride. What is the product here? We get CH3, that is methyl cation, CH3. Okay, CH3 plus, and about here the chlorine is combined on with this chlorine. Okay, so we get AlCl4 anion. Okay, that means we are saying the methyl cation. This is the methyl cation. This is about the tetrachloroaluminate ion. Okay, tetrachloroaluminate ion. Okay, this is about the methyl cation. Anyhow, this is what? An intermediate. This is what? An intermediate product. AC. Can we say AC? This is we can be taken as A. This is about the C. We get AC. Here, that is called what? Intermediate. Here, intermediate. Anyhow, this intermediate on react with other reactant. This intermediate on reacting with other reactant, that is CH3 plus AlCl4 minus plus, we are taking benzene. Okay, we are taking what? Benzene, that is C6H5. Sorry, C6H6. Benzene. Okay, C6H6. Here, methyl on combines with C6H6. Okay, methyl on combines with here. Methyl on combines. What is the product here? One of the hydrogen should be leaving out. Am I right? So, C6H5 CH3 plus one of the hydrogen combines with the chlorine. So what's the product? HCl. So what's the remaining? AlCl3. Okay, aluminium chloride. Okay, anyhow, this is our respective product, that is AB. This is C is regenerated. Okay, this is about, we can be taken as what? AB, that's AC. AC is an what? Intermediate. This we can be taken as, okay, B. Okay, so we get AB plus C. This is an example. Next about, we can be discussed on another more example. The decomposition of potassium chloride. Decomposition of potassium chloride, that is of potassium chloride. That is potassium chloride undergoes decomposition to form KCl plus O2. Potassium chloride and oxygen. It should be balanced equation 3 oxygen, 2 oxygen. So make it 2 here. 2 oxygen, 3. Already we balanced, already many times we learned this question. Anyhow, so what's the next reaction? Here the potassium chloride on reaction with manganese dioxide. Potassium chloride on reaction with the manganese dioxide. Here Mn plus O, MnO2 plus O is MnO3 plus potassium combines with chlorine to form KCl. How can we balance the equation 3? Make it 2 here. So we also make it 2 here. Okay. Next about here, oxygen is not balanced by adding. We can be adding easily. Method is by adding. Here we can be put on 6. All the equation is balanced. Okay, am I right? Anyhow, what is the name of this compound? MnO3. Can you say what's the name of this compound? Please. MnO3 name. Manganese 6 oxide. 6 oxide. Okay, because due to the oxidation state of oxygen is about manganese is about 6. I think that we can find out that one MnO3. How can you find out the oxygen state for Mn? X plus 3 oxygen, 3 into minus 2 equal to 0. X minus 6 is equal to 0. X is equal to plus 6. Okay. So manganese 6 oxide. Here, don't forget that. Okay. Next about, this is an intermediate. Manganese 6 oxide is what? An intermediate. So the manganese 6 oxide is again converted into MnO2. MnO2. Okay, here that is MnO3. And again converted into MnO2 plus oxygen. The easy way to balance the equation already we learned. Like it 3 here. Now the equation is balanced. Okay. Anyhow, the third example. What is the third example? Here, the formation of water due to the reaction between hydrogen and oxygen in the presence of copper. The formation of the water due to the reaction between hydrogen and oxygen in the presence of copper. First of all, copper, that is copper reacts with oxygen to form Cu2O. How much copper is there? 2 copper, make it 2 here. Okay, here. What's the name of this compound? Copper 1 oxide. Copper 1 oxide. Copper 1 oxide. Otherwise called, we can be say dicopper oxide. Dicopper, because copper having 2. So we can be say dicopper oxide. Anyhow, as you understand. Okay. Anyhow, this is one of the intermediate. What is that one? This is one of the copper oxide is an copper 1 oxide is an intermediate. So we can write as Cu2O plus Cal2. Okay. So what's the product? Can you say hydrogen combines with oxygen to form water H2O. So copper is left out. Okay. There is plus Cu Cu. Okay. This is about the second example. I think that it's a very easy equation. Next about we can learn about the fourth example. Okay. From the examination point of view, we can select any one equation is enough. Okay, any one equation, but I feel that you should try to write the first equation. Okay, that is better for you. That is your choice. Okay, anyhow, example 4. What is example 4? The oxidation of HCl by the presence of CuCl. CuCl2, that is copper chloride. Okay, copper 2 chloride. That is CuCl2 on reacts, it can be undergoes decomposition to form Cl2 plus Cu2Cl2. Okay, here can you understand? Copper 2 chloride Cu2Cl2. Okay, anyhow, here we should balance the equation. How much copper is there? 2 copper. Here I have only 1 copper, so make it 2 here. So how much chlorine? 4 chlorine. Okay, now it is balanced. Again we are taking Cu2Cl2. Again react with O2. So what's the product? 2 Cu2 OCl. Okay, 2 copper make it 2. Now the equation is balanced. Okay, here this is an intermediate. This is an what? An intermediate. This intermediate product, this is a catalyst. This is an intermediate. Again react with the HCl. So here what is the product? Copper reacts with the chlorine to form CuCl2 plus hydrogen combines with the oxygen. Hydrogen combines the oxygen to form here water. So how much oxygen is there? 2 oxygen. So make it 2 here. How much hydrogen is there? 4 hydrogen. Make it 4 here. Now the equation is balanced. Okay. Next about what are the limitations for example. Listen all of you. For the examination point of view, you should be learn the limitation also. Okay, limitation. What is the limitation? Here, intermediate compound theory failed to explain the action of catalytic poison and also activator. Okay, he fails to explain the action of catalytic poison and activator. Okay, what is about the activator means promoter. What is about the catalytic poison? The next question we can discuss that promoter and also that catalytic poison. The promoter is nothing but certain substance increase the activity of the catalyst. Some of the substance can increase the activity of the catalyst. Next question we can discuss. Anyhow, what is the next limitation? He unable to explain the mechanism of heterogeneous catalyst reaction. Intermediate compound formation theory is already I told you that it is a homogeneous catalyst reaction. But here what is the limitation? Limitation means he is unable to explain the mechanism of heterogeneous catalyst reaction. It's the first limitation, and also one more limitation. He failed to explain the action of catalytic poison and also the activator. Okay, we can discuss about what is activator and what is about the catalytic poison. Okay, I told you that promoter, activator is other name is called as a promoter. Certain substance promote the activity of the catalyst. That is the meaning. Okay, what is about the promoter? Promoters. Here, certain substance increase the activity of the catalyst. Such substances are called as a promoter. For example, the Habeas process, hydrogen combines with nitrogen. It can be taken as nitrogen combines with hydrogen to get ammonia. Am I right? So you can balance the equation 2 nitrogen, make it 2 here. How many hydrogen? 6 hydrogen. For this reaction, who is the catalyst? That is iron Fe act as a catalyst. Who is the catalyst? Fe, iron act as a catalyst. Here we are adding one more substance, increase the activity of the catalyst. We are adding one more substance which increase the activity of the iron. That is called what? Molybdenum, MO. MO act as a promoter. Okay, MO act as a promoter. Certain substance increase the activity of the iron or increase the activity of the catalyst are called as promoter. Otherwise, one more also we are using here, that is called aluminium trioxide. Aluminium trioxide is also using for increase the activity of the iron. Anyhow, what is about the catalytic poison? Certain substance when added to the catalyst reaction, it may be decrease or completely destroy the activity of the catalyst. That substance are called as catalytic poison. Okay? Certain substance when we added to the catalyst reaction decreases or completely destroy the activity of the catalyst. For the example, what is the example means? The reaction between about that sulfur dioxide. Okay. SO2. Sulfur dioxide on react with oxygen. Sulfur dioxide on react with oxygen, we get SO3, sulfur trioxide. Here we are using one of the catalysts is called platinum. Okay? Which catalyst we are using? Platinum. Here, platinum is poisoned by arsenious trioxide. Arsenious trioxide, AS2O3. Okay, anyhow, when we add in this reaction, the arsenious trioxide destroy the activity of the catalyst platinum. Destroy or decrease the activity of the catalyst. Okay, that's an example. And another one more example. The nitrogen combines with hydrogen to form ammonia. You have to balance the equation. Done. Here we are using which is act as a catalyst. Iron is act as a catalyst. Here one of the substance we are adding to destroy the iron. That is about the hydrogen sulfide. when we add a hydrogen sulfide to this reaction, it will be completely destroy the activity of the ion. So we call this a catalytic poison. Catalytic poison. And one more example also having hydrogen peroxide. Decomposition of hydrogen peroxide. Otherwise we can written as H2O on reaction with O2. We get H2O2. We have to balance the equation 2. Now the reaction is balanced. Here we are using platinum is act as a catalyst. When we add in carbon monoxide, the carbon monoxide destroy the activity of platinum. Destroy the activity of platinum. So it is called as what? Catalytic poison. Okay, these are the examples about the catalytic poison and also the promoters. Next we have to discuss about the autocatalyst and also negative autocatalysis and also the negative catalysis. Okay. Here, automatically one of the reaction. What is about that? The reaction, in certain reaction, one of the product formed act as a catalyst to the reaction. One of the product act as a catalyst. Such a type of the reaction we call as autocatalyst. Okay, in certain substance, in certain reaction, one of the product formed act as a catalyst in the reaction. Okay, sometimes initially the rate of the reaction will be slow, but with the increase in time, the rate of the reaction is increases. Okay, for example, it can be taken as methyl acetate. What is the formula for, ethyl acetate? What is the formula? CH3, COO, C2H5. Ethyl acetate. Don't forget that. Ethyl acetate. Ethyl acetate. Here, what is the reaction? It reacts with the water. So, first, water can be written as HOH. Am I right? Here, acetate reacts with the hydrogen. Acetate reacts with the hydrogen to form acetic acid. What is the formula for acetic acid? CH3 COOH plus C2H5OH. C2H5OH. Am I right? C2H5OH. The name of the compound is ethyl alcohol. So, what's the name of this compound? Acetic acid. Okay, here acetic acid is a catalyst, autocatalyst. Okay, here which one is a catalyst? Acetic acid. Which one is a catalyst? Acetic acid acts as a catalyst. It's one of the very important question. Autocatalysis. Okay, what is the question? In a certain reaction, one of the product formed acts as a catalyst to the reaction. Clear? So, one more example is also we can write as arsenic trihydrate. The formula is AsH3. Arsenic trihydrate. This on decomposition we get arsenic plus hydrogen. Okay, how to balance the equation? Make it 2 here, 2 arsenic and hydrogen 3. Okay, here also arsenic acts as autocatalyst. Which acts as autocatalyst? Arsenic acts as an autocatalyst. Clear? Then about the one more question. About the negative catalysis. Okay, negative catalysis. Some of the reaction when we adding certain substance, the reaction is increase or maybe decrease. Suppose the reaction is decreases, it is about that what? A negative catalysis. Negative catalysis. Okay. Anyhow, presence of certain substance decrease the rate of the reaction. Don't forget, decrease the rate of the reaction. For positive catalysis, increase the rate of the reaction. Here negative means decrease the rate of the reaction. Okay, so it is called as what? Negative catalysis. For example, we can be taken as chloroform, CHCl3, chloroform. This one undergoes react with oxygen to form carbonyl chloride. Carbon combines with oxygen to form carbonyl chloride, COCl2, carbonyl chloride. And also we have hydrogen combines with oxygen to form water. And also chlorine is leaving out. So, what are the products are obtained? Chloroform react with oxygen to form carbonyl chloride, water and also chlorine. How can we balance the equation? The best way is for easy to make 4 here. So how much carbonyl chloride? 4 is there. How much chlorine is there? Out of 4 is 8 over. Then we have 2. Then how much hydrogen is there? 4 hydrogen. So make it 2. Oxygen also 2. Okay. Now the equation is sorry. Here also having 4. Here also. So make it 3 here. Now the equation is balanced. Here. When we are adding ethanol to this reaction, when we are adding ethanol, what is the formula for ethanol? C2H5O. That is called ethyl alcohol. The common name is ethyl alcohol. The IUPAC name is ethanol. When we are adding ethanol or ethyl alcohol, okay, what happens means the rate of the reaction is decreases. Okay, the rate of the reaction is decreases. And also one more example. Hydrogen peroxide H2O2. This on decomposition to form water and also we get oxygen. Water and oxygen. We have to balance the equation. 3 oxygen, 2 oxygen, make it 2 here, 2 here. Now the equation is balanced. Okay, yeah. For this reaction, we are adding one of the catalysts for the decrease the rate of the reaction is we are adding is glycerol. Glycerol or glycerine. Okay, glycerol or glycerine, and also one more we are adding dilute acid. These are all what? About the negative catalysis. Okay, negative catalysis. Okay, don't forget for each one. That means whether maybe the promoter or maybe the catalytic poison or maybe the autocatalyst or maybe the negative catalysis. You should be learn the definition. For one line definition is enough, and also you should be learn one equation. Okay, one example. Example is compulsory. There, an example is compulsory. Okay, clear. Okay. So what is about the promoter? Shall I ask one question? What is about the promoter? The promoter promotes the activity of the catalyst. Okay, the presence of certain substance increase the activity of the catalyst. Such substance are called as promoters. Okay, and about that, what is about that negative catalysis? Certain substance when we add it, the rate of the reaction decreases or maybe completely destroy the activity of the catalyst. That is called a catalytic poison. What is about the negative catalysis? Here, presence of certain substance decreases the rate of the reaction. Okay, which are the substance we are using for the negative catalysis? For example, the chloroform is converted to carbonyl chloride. We are using ethanol or ethyl alcohol. Anyhow, hydrogen peroxide decomposition, we are adding glycerol, glycerine and also dilute acid. Okay, so can you remember what is the formula for glycerol? Previous day, before previous day I told you that the formula for glycerol CH2OH, CH2OH. Am I right? This is the formula for glycerol, and also the molecular formula. How much carbon is there? 3 carbon. So make it C6. How much hydrogen? 2 plus 1, 3, 4, 5, 6, 7, 8 hydrogen, 8 and oxygen, 3, O3. This is the molecular formula and structural formula for glycerol. Okay. Anyhow, today our assignment. What is the assignment means? You should be write the intermediate compound formation theory. Okay. That means only the theory is enough, and also write any one example, not all example, any one example, intermediate compound formation theory. Seven, okay? And any one example. Okay? Please all of you take the textbook. I mark and give the page number. That's a page number 18. Second volume, page number 18. The intermediate compound formation theory. The catalyst act by providing a new path with low energy of activation. In homogeneous catalyst reaction, a catalyst may combine with one or more reactant to form an intermediate which reacts with other reactant or decomposed to give product, and catalyst is regenerated. Consider the reaction A plus B gives AB, A plus C gives AC, C is the catalyst, AC plus B gives AB plus C. Okay, that much. And also write any one example. You select any one example as per your decide. Okay. Those who are willing to write the limitation also. Sometimes it may be asked about that 1 mark. Okay. So limitation also. Okay. Please all of you write the assignment. Intermediate compound formation theory, and also write any one example. That much enough. Okay. Thank you all of you. Thank you. Have a nice day.